Good evening, everyone, and we'll start now the seminar. Good evening, everyone, and welcome to Sheikh Abdullah Salim Culture Center's series of talk with Kuwait Institute of Scientific Research, KISR. Thank you for joining us. I'm Hanouf Jassim Al-Faylakawi. I'm a facilitator from a Natural History Museum at Sheikh Abdullah Salim Culture, and I will be the talk moderator this evening. These talks seek to highlight the scientific, educational, and cultural efforts made by KISR, which contributed to supporting the scientific progress of the State of Kuwait. The talk will be 45 minutes, and the last 50 minutes will be for discussion and question. So, our guest of evening is Dr. Wafa Al-Rashid. Dr. Wafa posts an impressive resume, and it's currently an associate research scientist at the Ecosystem-Based Management of Marine Resource program under the Centers of Environment and Life Science Research. And today, she will be talking to us phytoplankton and their impact on our marine resource and biodiversity. Welcome, Dr. Wafa. You can start now your seminar.
Thank you. Okay. My lecture is on phytoplankton and their impact on marine resources and biodiversity. Let us ask the question, what is marine phytoplankton? They are macroscopic algae living in the water column, and they exist either in single cell or in chains or groups. And there are about 5,000 species of marine phytoplankton. Phytoplankton come in communities. They are composed of 4 major phylogenetic groups: the cyanobacteria, which is the prokaryote cells without a nucleus, and the others is the eukaryotic one, like the diatoms, dinoflagellate, coccolithophores, and naked flagellate. Now, about the size of the phytoplankton, they are distinguished in different sizes. In their diameter, we have the macroplankton, more than 200 micrometer, microplankton 20 to 200 micrometer, nanoplankton 2 to 20 micrometer, and picoplankton 0.2 to 2 micrometer. The main 2 classes, they are the diatoms and the dinoflagellate. Diatoms composed of 2 valves. They are from silica frostule, and these diatoms living in the water current, mean it move with the water current as the seawater move. Dinoflagellate, they have a flagella, help them in their swimming. As you see in the 2 pictures down, we have 2 flagella, one around the cingulum and one of the circulus, and these help her in their moving different direction while swimming and to give her energy for swimming. Also, the body of the dinoflagellate is composed of thecal plates. How the phytoplankton live? They are running photosynthesis using the carbon dioxide and water in the presence of the light energy from the sun and the chlorophyll pigment, and then producing the carbohydrate and releasing the oxygen. What the phytoplankton require? They require different inorganic nutrients like nitrate, phosphate, and others for living. And there are some gases is dissolving in the water to be used by the phytoplankton for their growth. Now, how these phytoplankton reproduce? As we said, the main 2 groups is the diatoms and the dinoflagellate. We can see that the diatoms, they are running binary fission. The 1 cell, it goes to 2 cells, and 2 cells to 4, and then increasing the number. Also, they have sexual reproduction if in unfavorable conditions. Also, we have for the dinoflagellate, they're running the same thing. They have sexual and asexual reproduction. Asexual reproduction, they are undergoing primary fission. The 1 go to 2 and the 2 to 4, and then increasing in number. Now, the marine trophic levels in marine ecosystem. What are the trophic levels in the marine environment? We have the phytoplankton. Phytoplankton, our creature here in the lecture, is the foundation of the marine ecosystem. And as we said, it's going to undergo photosynthesis. And it is the primary producer for the ecosystem. Comes after that, phytoplankton is the zooplankton. And they are the primary consumer. And also they are the secondary producer after the phytoplankton in the trophic level. There is other primary consumer like small fish, snails, shrimp, clams, and crustaceans. Primary consumers, in turn, they will be eaten by fish, sharks, corals, and flying whales. Then we have the decomposer. The decomposer exists in the trophic level, each trophic level, because it's like mainly bacteria, break down the dead organisms and working on the waste of the organism. This process releases nutrients to support the primary producer as well as the consumer that feed on absorbing organic material. This process is very important, and even in top level consumer are contributing to the food web. As the decomposer, as I said, it's breaking down the waste and the dead tissue. You see in this pyramid how the trophic level is living in the ecosystem. We have the phytoplankton, the primary producer, coming after the herbivore consumer, then the first carnivorous consumer, then the second to the top carnivore. And in each level, we have the decomposer working on the dead organisms and the waste and releasing some energy. But as we said in the beginning, the phytoplankton is running on the photosynthesis. So phytoplankton is the base of the food pyramid. As you see here, the phytoplankton in the base, it's the main and big layer in the food pyramid. Depending on it, all the other trophic level coming in the different levels till we are reaching the fish at the end. And then also for the food chain, the phytoplankton is the beginning, and it's depend on it all for feeding the zooplankton and the other fish till we're reaching the last one. So it's the main primary producer for the marine ecosystem. If we go more complicating for the food web, we find the phytoplankton is the main source and in the food web. Coming after it, zooplankton and some other organisms which they are feeding directly on the phytoplankton as some of the herbivore fish. And then the all arrows of the all organisms at the end goes to main, it's the human being. But as we said, the base of this all food web is the phytoplankton. Again, here, phytoplankton provide food for a wide range of sea creatures. We have here like the whale, we have the zooplankton and the shrimp, and snail, and the jellyfish, and the small fish. Now, we will speak here about the blooming of the microalgae and how this bloom is happening. We know that the phytoplankton, I say, they are dividing binary region, but sometimes when they are grow rapidly and reach a very high number, more than 1 million cells per liter, or reaching in the measurement of the chlorophyll, more than 20 microgram per liter. This will cause like coloration in the water and make like patches in the seawater, and this phenomenon called red tide. So the red tide is development of a monospecific bloom of one species of the microalgae. Is there a type? It means a red type always come in red? No, it's come in different color. We have the blue, green, brown, white, according to the species, which is a bloom, and according to the reflection of the light from the sun. Now, algal blooms. Algal blooms, they are different, which we said the increase in number or rapid growth of one cell of the phytoplankton. We have the non-harmful one. It means acceleration of the water, but there is no negative effects on the environment. And we have the harmful. The harmful if the creature have sharp spines and affect the gills of the fish, or producing a mucus, which also affect and clog the gills of the fish, or cause suffocation to the fish by decreasing in the oxygen in the water. So different ways it can, the bloom be harmful to the fish in the sea. The other one is the toxic one. There is some of the algae have toxins in their body, and these toxins, it's affecting, usually accumulating in some of the shells, or accumulating in, or affecting the fish, and will be toxic to the human being if they feed on. This is the colors of the red tide from the world. We can see like blue, white, and also other colors for this red tide. Now, if we go to the some blooms in the world, we have in the Arabian Sea on 17 February 2009, we have Nyctiluca scintillans. You can see the bloom of this creature in the sea, how much the patches is big on the sea. And this is the creature is one of the dinoflagellate causing this type of bloom. Now, this is another one, which is Phyocystis, and it's a type of colony and has the flagellates inside. And this is one of the creature inside this colony. And it's causing also producing irritant substances, which cause fish kill to the fish where are swimming with this type of bloom. This is another bloom. This type of a creature, it is the cyanobacteria, the species Trichodesina. They are coming in bundles, and the bundles aggregate each other, making like a big bundle of some cells. And the bloom of this is showing in this picture. And also this is can cause a fish kill. Here another picture showing the Chatonella, one of the species which cause, which bear toxin and cause fish kill. As you see in the pictures, how much the fish kill in this country. And the toxin, it was neurotoxin, and the creature, it was, or the dinoflagellate, it was Chatonella, one of the flagellates. Here another picture show you how if the bloom happen in the sea in the batches, usually the bloom is moved by the current from part to part in the sea, and it can attack the sea cages in the sea. And you can see here how is the fish all dead in this cage. Why? Because the usually the phytoplankton, they are moving with the currents in 1 meter, and they can attack these fishes in the sea cages and kill them, because there's no way this fish can move from the sea cage. There are some solutions for this type of sea cages to protect them from the harmful algal bloom. Either you have some spare sea cages and you can transfer the fish to the other new cages far from this patches and harmful algal bloom, or you can lower the cage to in a way that when the bloom come and touch this surface, they will not attack the fish because they are not in the same level. The other way the harmful algal bloom can be transferred from a country to another country is the ballast water. Sometimes when an oil tanker have the oil and go to a country and remove their oil to the country they are reaching, and then they have to replace this oil with a seawater from the same country to balance the tanker. And then when they reach their country, they release this oil water to their own country. Sometimes this water is having some of the bloom of a previous country they go to it. And these creatures, when go to the sea, they will divide and create a bloom. So it's like invasive species transferring through the ballast water by oil tanker. Now we'll speak about some red tide, which is happening in Kuwait waters. We have in September 16, 1999, a fish kill occurred by the Carina silformis. It's one of the dinoflagellate. And in this time, there's a big number of the wild mullet. They died, around 30 tons, and mostly in Kuwait Bay, and take a period of 2 to 3 weeks. Also in October, the second fish kill, it was in the sea cages for the European sea prey, and it's around 150 tons. They are died, as I said, the sea cages, it was in Doha. And also it's the same case, it's the same species, Carina silformis, within a period of 2 weeks. This is one of my studies during that case. As you see in the graph, that from 2 million to more than 7 million of the cells of the Carina silformis, is the light blue. So during this bloom, it reached in million cells per liter of this creature of dinoflagellate. This is the Carina silformis in 1999 from Kuwait waters, and you can see this organism, how it looks like. It's only a dinoflagellate. It's a complete cell with a nucleus, and it has the flagella. One flagella will be here around, and one flagella will be here, but it's not clear in this picture. But as we said, it's moving by its flagella. Now, the question, what is the impact of the HAB on the gills? We are speaking here only about the Carina silformis, what they are doing. They produce ichthyotoxin. This ichthyotoxin damage the fish gill by causing hemolytic effects that is destroying the blood cell. Then the fish, as protecting themselves, they produce a big mucus layer on their gills, and then at the end they will suffocate and die. So that's how the Carina silformis work on the gills. This is the normal gills, and this is after the attacking of the Carina silformis to the epithelial cells of the gills. This also to show you the fish kill, how the big number of mullet on the beaches in 1999. And here to show you how the army and the student working to clean the beaches from the dead fish. Now, this other plume of other species, this is in Phytoblankton 2002, and it was by this creature. It's a diatom. It's called Mistia, and you see it's blooming, and here causing the coloration of the water because of this plume. This is another plume by a flagellate called Denunella salina. It's living in high salinity water. In this one, there's no fish kill. It's a non-harmful one. In October 2004, and it's give a coloration of red to the seawater. This is another one, which is a plume of Phytocystis. Phytocystis, it's, as we said before, it's a colony, and it's composed of a number of flagellates, and here the different colony in the bucket. And how you see the water is coloring to red. And this happened where it's in KISR Marina in November 2005. And this is another plume. This Myrorecta rub plume in 2009 and then in 2014 and 2015. It is an autotrophic ciliate. It's not an algae, but it's running photosynthesis. And this it's blooming nearly every year, but it's not causing any fish kill, only coloration of the water. If we want to speak about the fish kill, another fish kill in 2001, the main one we speak before is 1999. The other one in 2001. In August 2001, the weather was humid and the temperature is high and low dissolved oxygen and high salinity. This make the immunity of the fish is weak and led to get attack of this fish by a type of a bacteria called Streptococcus agalacti. And in this occasion, 2,600 tons of the mullet died. So, and the remaining of the fish for a long period on the beach and in the water with the calm weather make the disease epidemic. Here we can see the bacteria. This I reported because it's a fish kill, and the bacteria is the reason for that. The fish suffer from severe reddish spots in the head and under the fin, and ulceration, bleeding in the internal organs, and the gills within the mucus. As you see here in the picture, some reddish on the mullet, which is died because of this bacteria. And here you can see how much of the fish died in the sea only because of this bacteria, because it became like an epidemic and most of the fish died. Most of the fish which is died is mullet. Mullet because they swim in school, and usually when they swim in school, they get attacked by anything to kill them, like the bacteria or the algal bloom, and then they died, and because they come in huge number, and at the end we get a huge number in tons killed because of this. We have another occasion here, a fish kill in 2005. It was sardines, the fish, and it was in Salmiya Marina, which is KISR. This fish come to the marina, and then there was a low oxygen in the water, and which is suddenly they got died because they suffocate because of low oxygen. We have another occasion in 2009 when we have the breakdown of the waste treatment plant for Mishref, and then we get in Al-Bida and at SAS Hotel and Masila, they are dropping all the sewage water to the sea, and causes polluted by the sewage. You can see how is the coloration of Al-Bida outfall and the coloration of SAS Hotel outfall, and here down to show the breakdown of the Mishref the plant for sewage treatment. In 2011, we get a fish kill southwards. South Kuwait shore southwards, and we have a rescue center in Salmiya and in Masila. And all what's happened is because of the low oxygen and the species which is died, it was Salmonella from Salmonella. You can see here the picture. This is in Salmiya Marina for KISR, and this is the rescue center. And here we have the Masila. How much of these fish being died is also these because of low oxygen. We speak before that there is some toxic dinoflagellates. These toxic dinoflagellates, as we said in the beginning, they have the toxins in their body. And usually it enters the shells when, as we know, the shell is a filter feeder. So, and these organisms goes and accumulated in the shell. We have different diseases or poisoning come out of these different dinoflagellates. We have ammonastic shellfish poisoning, which causes memory loss. We have neurotoxic shellfish poisoning, which attack the nerve system. And we have diuretic shellfish poisoning, which cause diarrhea and nausea. We have paralytic shellfish poisoning, which cause paralysis. And then we have secretarial fish poisoning, but this is attacking only the fish, and it kills the fish, and the fish usually or accumulate in the body of the fish, and the fish will cause for the human being intestinal problem. So all these creatures, if they have toxins in their body and the human eat it, they will get some problems in health. This is an example of the Secretarial fish poisoning. As we said, it will, here the dinoflagellate, and here the herbivore fish. They are feeding on this another type of the dinoflagellate, which is benthic. They are feeding on the benthic dinoflagellate. It's a herbivore fish. Then the carnivore fish come to eat this herbivore fish, and all accumulating in their body, and at the end it will reach a human being and get some intestinal problems. Now, what is the solution for this algal bloom? There is different solutions, but mainly most of the countries use the clay dispersal. So the clay dispersal is work like this. They disperse the clay to the surface where it has the dinoflagellate. This clay will accumulate into large particles, attaching this algae, and then make their weight heavy. And then at the end, they will sink. The dinoflagellate will be break down and died because of crashing and because of no sunlight. Other solution for algal bloom we have in small scale. If we have a bloom of dinoflagellate, Carenia brevis, this is an example in Florida. They use, run this experiment in a large tank, zap it with ozone. They use the ozone gas, and this is highly reactive molecule, both kills the red tide organism and breaks down the toxin it produces into harmful harmless byproducts. Now, what promote harmful algal bloom? As we see from all these slides, the things which promote harmful algal blooms is excess nutrients coming from decaying algae, unmanaged sewage and industrial discharges. This is the man-made activities, fish farm nutrient enrichment, polluted waters, lack of a grazer or consumer of this lifetime, or condensive physical, chemical, and biological conditions that promote rapid growth of this algal cell. What causes the different mortalities in Kuwait and the region? Untreated sewage through outfalls, eutrophication. This eutrophication, that's when we get a big number of cells of algae, and then when they are dyed and decomposer they work on it, then we'll get a huge inorganic nutrients, which is causing also a decrease in the oxygen, and we have more nutrients in the water. Bacterial infection, algal blooms, hypoxic conditions, which is low in oxygen, dredging of the beaches, and discharge of chemical compounds through drainage of, from factories, and the oil spill. Other causes for the mortalities, it's in the desalination plant, when they're using hot water for recycling the water in their system. This will cause enrichment of large number of fish and macroinvertebrates, and then they died at the end. Sudden changes in temperature, salinity can cause mass mortality of fish by disrupting the osmoregulatory mechanism of the fish. All these mortalities, it's impacting the economy and will cause like closure of the fisheries, affected aquaculture activities, coastal tourism, damaged coral reef, and force the closure of the desalination plants. This is one picture to show you the pollution of the marine environment. Like here we have some oil slick in 2002, and you see how all the garbages is being dumped to the sea and cause a pollutant environment. Unbalanced marine ecosystem. As we know, the fish are an important part of the marine food web, and if they die by the harmful algal bloom, can seriously impact the entire food chain, bringing about changes in the trophic dynamics of entire ecosystem and impact the overall productivity of the ecosystem. The more direct implication of fish kill include impact also on the birds and other scavengers, that they could die of feeding or consuming the contaminated dead fish coming off this, they died in the beach. So massive fish kill, the decaying fish seriously deplete oxygen and impact the marine life. To protect Kuwait's marine environment for sustainable resource utilization, you know the Kuwait marine ecosystem composed of coral reef, Popian Island, southern soft coastal, and open sea ecosystem. And this all, they have some overfishing, habitat destruction, and exposure to direct or indirect man-made. So we have to take care of this marine ecosystem. Also using the ghost fishing, it captures the marketable and undesirable fish and should be replaced by the biodegradable cotton lines. The island of Murad, Garo, and Cooper are rich in Malaf coral reef and serve as natural nesting grounds for birds and turtles. Their fragile equilibrium endangered by unsustainable human activities, which is disposable of the waste. Here we can see a picture of a marine ecosystem. Any marine ecosystem, depending on a keystone, For marine ecosystem, we have the phytoplankton should be in a healthy number. So because all the trophic levels is dependent on them. Here we have an example from New Zealand. The sea star is the keystone species, and it's controlled the number of mussels. If we remove the sea star, the result will be a high number of mussels, and this has flow-on effects on the other trophic levels in the food web. Now, unbalanced marine ecosystem, and here we will be speaking about the phytoplankton. If pollutants such as crude oil spills, organic pollutants, heavy metals, and household wastewater, all affecting the phytoplankton communities at different levels: abundance, growth, dominance, and succession patterns. And also, as we know, if the plastic is being thrown to the environment, it will block the light from plankton, and the plankton will die from suffocation or not undergoing the photosynthesis. So this is to show you that unbalanced marine ecosystem can happen if the phytoplankton is being affected. So how we can get a balanced, healthy marine ecosystem, marine environment without pollutants, crude oil or organic pollutants, heavy metals, or household wastewater, will have a positive impact on our big keystone, the base of food pyramid, the phytoplankton. So it will affect their abundance and growth, and it will be in a healthy manner. Then the other trophic level, which is coming the zooplankton, they are depending on this healthy beginning, which is the phytoplankton. They will live healthy, and they will affect the other trophic level in the food web. And at the end, we'll get a normal, healthy marine environment. The result is sustainability of the marine resources. All marine resources in the food web or pyramid or the chain will be living healthy. It will be a balanced marine ecosystem, and then we'll conserve all the marine biota. So all will living as producer and a consumer in a healthy manner. Finally, it will be the biodiversity of all trophic level will be maintained. And this is how we can get maintaining of sustainable marine resources and a high biodiversity, and keeping a normal, healthy marine ecosystem without any pollutants. As recommendations, we have to take care of our environment and not throwing anything to the sea. And also, there is a daily monitoring of sewage thrown through the outfall to the sea, ballast waters. As we know, there is around 53,000 ships passed as oil tankers in the Arabian Gulf. Improve the water circulation, especially in the closed marinas, and stop throwing the factories, laboratories, and hospitals waste to the sea. So thank you so much for listening.
Thank you for the very incentive talk, Dr. Wafa. It was an amazing seminar and benefits information. Thank you so much. And now, if you have any question or input, please just type them into the chat. We'll wait. Okay. The first question, Doctor, is there another safe way to get rid of the algae before it's disease?
Before it happens, you mean?
Before it's happening.
Yeah. The solution for the algal blooms There are a lot, but the main one is being using is the clay. The clay is a safe way to disperse it on the batches and then get it destroyed. And I saw this is using in Korea. They using the ship and just they are dispersing this clay. Sometimes they put like buoys in the sea just to get measurements of like a chlorophyll, and the chlorophyll will reflect like the cells in the sea, which is mean the bloom. So just to be alarmed that there is like a bloom coming in the way. But most of the solutions they use like a parasites, they use a bacteria. It's on a small scale. Yeah. You know, because you cannot put anything to the sea because the sea is full of other creatures. You don't want to affect other creatures. Only this small dinoflagellate. So as I know, the clay is the safer one.
Okay. The second question, can tox macrolage still affect us even if the fish is cooked?
Oh, you mean the dinoflagellate after cooking the fish? As I know that the toxic one, if you eat a raw fish, it will affect you like the Japanese feeding. But better not to eat even after cooking because you don't know this creature, maybe it's in the tissues accumulated. So better not to go and eat some fish while you have some plume or toxic of any these dinoflagellate in the water. So you have to stop feeding on this or catching these fishes.
And the other question?
The question is, what can graze or consume the red tide algae?
Oh, I give one example. Some of the plume, they are good as a food for the fish. In one of my slides, the Neolella salina, it's a good creature for the fish as a food to graze, to feed on it. But not everything. Some of the species, it's only coloring and it's good for a food. The example is the Neolella salina as in my slide.
Yeah. And the third, what causes eutrophication to happen in Kuwait?
Eutrophication. Usually it's a normal phenomena. If the organisms, they are increased in number and then they died. When they are dying, the decomposer working on them for decaying. And when they are decaying, they are transferring the organic matter to inorganic. An increase of this inorganic in the water, it's caused the eutrophication. So it's something start like increasing the number of cells, after it comes the eutrophication. And sometimes also dumping of the sewage, and also it causes high nutrients. But mainly eutrophication, it's the decaying of the dead cells and transferring by the decomposer from organic to inorganic.
The other question, how can I help the marine environment on a person or a personal level?
This is an easy question. Every person is in charge of his environment. If we go to the beaches in Kuwait, you are in charge of cleaning everything you can see. If you are really care about your environment, just go to the beach and see how many plastic, how many bottles, how many garbage is being thrown to the sea. Even we are in a period of Corona, it's and the beach is not being used for a long time, but people start throwing the things again. And the plastic, as we know, it's make like a barrier to the sunlight, and it will kill a lot of creatures in the sea. So this is a personal help they can do.
Okay. How can water circulation in Kuwait be improved safely?
Usually, as we said, that some of the marina that has no circulation of the water, there is some machines can be used in a way to be in a safe place, not affecting the creature, to circulate the water in a closed marina, but will not circulate it in the main open sea, only on the closed marina.
Yeah. What exactly are ballast water, and are they only from tankers?
Yeah, the ballast water usually it is, as I said, oil tanker go to a country and drop their oil. They cannot go back without filling the tank with something. So usually they fill it with the seawater, and this seawater, if it has some bloom, the tanker will go to their own country, and like they are transferring the bloom to another water area. So usually it's, oil tanker usually doing this job while we are working.
Okay, the last question. For the recommendation, how can we improve the water circulation in Kuwait by?
It's the same question I think before, how we can make a good circulation of the water. I think there's some of the authority in Kuwait, they are taking care of this, but long time ago, I don't know what happened. But as I said, to circulate, should be some machines to move the water from bottom to up, just to make some oxygen come inside the area. And mainly, as I said, mainly it's the closed marina. The open sea, you don't need circulation.
Okay. This is the last question. Thank you so much for joining us today. And we hope that you enjoyed today's seminar. We hope to be able to see you soon at Sheikh Abdallah Salim Culture Centers, where you can learn more about the topics today by seeing our amazing exhibit at the museum. And please don't forget to stay updated for our upcoming events by following us on our social media account. Thank you for listening. Thank you, Dr. Wafa. Hope to see you. Thank you so much. Thank you. Goodbye.